Copyright in these lectures is either owned by the ANU or a third party who has licensed the ANU to use it. Students may use the recording for personal study only. No lecture may be communicated online, copied or shared without the prior permission of the ANU.
Okay, let's make a start. All right, so today, as I said yesterday, we've sort of finished with chapter 4 of the notes. So we have one chapter to go, which is the time series thing, which is going to be for the second assignment, and we'll start that tomorrow. So now you should have all the base material that you might need to do the project. Okay, so if you haven't started the project, now's a good time to start thinking about it. To get you started today, we will start to talk about it a little bit. So that'll be at the second half of today's class. The first half of today's class will be spent talking about what everyone's probably already thinking about, which is the first assignment, and the marks are back. And as I said yesterday, I beseeched you, please don't panic, and please wait till today, we'll talk about it. 50 emails later, we're here. Okay. Suffice to say, people panicked and people emailed me and I failed. Oh dear. No, you didn't. So relax. Okay, we'll talk about what it all means. So let me just start, because everyone wants to know the summary statistics for what happened and why the marks look the way they look. So let's go through that first. And let's try and get a bit of a baseline for where people sit. Now, one thing I have to say up front is, and I've said this before, because assignments and the project are the only assessment we have for the course, I just can't give everybody 10 out of 10 like happens in a lot of courses. I mean, I just can't, because then I'd have 316 high distinctions, and my head of school would cleave my head open with an axe, because you can't do that. Right? So the goal in assessing and marking is to get you guys in some sort of order, okay? The raw marks themselves don't mean anything, and I'll tell you why. Because in the end, I have to scale them so that about 15% of the class ends up with an HD, about the next 20% ends up with a D, about the next 30% ends up with a credit, and most of the rest, probably all of the rest, end up with a pass. Okay, that's what the distribution of grades looks like in almost every course in the school. Okay, and it's a reflection of the fact that some people are up the top and some people are down closer to the bottom. And luckily in this course, the odds of failure are very low, because if you hand stuff in, you'll get enough marks to pass. Okay, so the first thing I want to put on the table is that, and you can see the distribution of marks here, right? I mean, I can make it big. There it is. You can see the lowest mark was about 10. Now, you know, I said this is out of 50. Well, of course it's not really out of 50, because no one got close to 50, and that's cool. All that matters is getting that ordering, right? Well, that's all that matters. The mark itself is not a measure of you or anything like that. It is simply where you sat in a class where the marks ranged from about 10 up to about 35, 36. Okay? So please don't send me an email saying, I got, 48%, so I failed. That is just not true. Okay? It is just not true. I'll give you a rough cut of where I think the grade boundaries will be. Okay? And that way, hopefully, you'll get a bit of a sense of where you sit currently. And I get that some of you will still be disappointed and will want better marks, and that's cool, because we should all want the best marks we can get. But the second assignment, generally, if history is any guide, marks higher than the first, because it's a little bit easier, I think, a little bit more straightforward. And then the project, it's pretty hard, but, every year I end up in a class of this size with about 15% HDs, and you guys can work out what 15% of 300 is. That's a lot of HDs, and so on. Okay, so the mark itself is not something you need to fret about. And I totally get that everybody here wants to do better than just pass. Okay, I get that. I totally get that. So let me have a talk about where the marks sat. So this is the 5-number summary of the marks. Okay. So yeah, the last mark was 10.5. The median was 26. The mean was 25. So roughly symmetric. And this is by design, right? An average assignment should get about half of what marks are available in total. Okay, that's kind of where it should sit. The course doesn't and can't go to the sort of grade inflation that we see everywhere. It just can't, because we don't have an exam. You know, this is not some weird trick, because you know that in a lot of other courses you have all these cream puff assignments where everyone gets 10, then you come and sit the exam and get absolutely hammered because stuff's on it that you never heard of before, right? I know that's how everybody feels. And then you go, oh my God, I failed suddenly, even though I got 10 out of 10 in all the assignments. And yet somehow people are comfortable with that. You shouldn't be comfortable with that. That's not reality, okay? That's a confection. So this looks much more like a realistic set of marks. Okay, so the top was 36.5. So the person who got 36.5, I don't know who it is. I can look up their student number, and if I wanted to, I could find out who they are, but I don't want to. That person's probably going to get near enough, 95, 96%, 100%, whatever, right? If this was the only piece of assessment, that would end up being roughly 100, okay? So that's the top watermark, okay? Now, like I said, about the top 15% get HDs, about the next 20% get Ds. So roughly speaking, 30 to 35% of the class will be in the DHD range, okay? So we can see here from the third quartile, 27.5, that's 25% from the top. This is comfortably in the D range, okay? And probably a little bit below that will bleed down to the bottom of the D range. So we're probably looking at, I don't know, and this is rough cut, okay? 27, maybe high 26s is probably putting you in the D range. The HD range is probably, I mean, we can look at the histogram and try and work it out. The HD range is probably, I don't know, 29, 28, something like that. Okay? And you go, well, why can't you tell us an exact number? Because it's pointless to do so. You've got 2 whole big pieces of assessment to come. I wouldn't be pinning too much on this. Okay? But that's just to give you an idea where you sit, right? So, you know, I get a lot of emails and people go, oh my God, I only got 27, I'm failing. No, if you got 27, you're probably sitting comfortably in the D range, okay? That is not failing, right? Not by anybody's metric. And that's why yesterday I said don't panic, and I really mean that. I don't want you to feel bad about coming and doing the course. I don't want you to feel bad about learning at all. No? I also want to tell you, this is on a very personal note, I hate the day I hand back assignment marks. I just feel awful. I feel awful that whole day and that whole next day and probably for a couple of days afterwards. I sit in my office with my head in my hands sometimes thinking, well, you know, why do I do this? Because I do understand how it feels to you guys. I mean, I remember when I was a student, it was a long time ago, but I remember it. And I remember how much marks meant to me, and I know how much they mean to you. That's why I want you to be very clear that the number that you get is not meant to be interpreted in the raw sense that a lot of people are trying to interpret it, okay? So, HD, I'm guessing 29, 28 and above, probably in that range. 28 might put you in the distinction range near the top, but remember, you've got other pieces of assessment that are going to push marks around, so don't fret too much about that boundary. I'm thinking the D range probably goes down to probably 27, high 26s, something like that. The credit range probably pushes us down to maybe low 20s, okay? 24, maybe, something like that, 24, 23, okay? And then the rest is in the P range, okay? Now, look, if you're right at the bottom of that, you know, if you're near the 10, and again, this isn't about who got 10 or whatever. Yes, I would pass that last one, okay? Probably it's a 50p at this point, that's fine, okay? If you're that person, again, I don't want you to go and put your head in a hole and go, this is dreadful. It's not dreadful. It can improve, and you've got 2 whole pieces of assessment to drag it up, okay, and get yourself comfortably into the P range or into the credit range, right? So I've seen quite a few people struggle in assignment 1 and come back and do very well, actually, in the course, okay? So I hope that gives you a bit more comfort around what your mark actually means, all right? This is not in any way, I mean, there are 2 things I want to say about this, and I think this should be said in every course. The first thing is, these marks are not you. They don't define you, and they shouldn't make you feel so sad or so desperate that, you know, you go and lie down for a week or worse, okay? I mean, it's 1 mark in 1 assignment, okay? And the idea was to put you in order, not to give you a mark that somehow defined you, okay? And I think it's really important for people to understand that about the way university operates, okay? The second thing I want to say about it, and I've got some feedback about this already, is a lot of people, a couple in particular, but quite a few people, express frustration about the way the assignments are. They're very open-ended. They're very, here's some data, you go explore it, okay? And so a criticism that I hear regularly is, well, we don't know what you expect, okay? Well, I'll tell you what I expect, and I think I've said this before, but I'll tell you what I expect. I expect you to explore the data to the best of your ability, okay? And then I expect you to tell me the story of where your exploration took you. And then, when you hand it in, I look at your exploration and because I've explored the data too, I then say, well, how far along did you get compared to where I think you might have got? And that's what the grading's all about, okay? And that's it. That's what I expect. Now, I'm not, and I'm never going to, come and say, okay, these are the steps I want you to perform in this assignment. If I give you the answer, that by telling you so clearly what I expect in terms of a rubric, then I'm utterly going against what this course is all about, right? And this course is all about, when you hit the real world, guess what? Data doesn't come with instructions. You just get dropped in it. And it's just expected that you'll know what you're doing and that you'll know how far an exploration needs to go and you'll know when you've got somewhere and all that. And this is a bloody hard thing to learn, right? When I left uni, I didn't know how to do that. Honestly, I didn't. Now, luckily, we didn't have much computing back then, so the need for it was less. And I knew a lot of theory. But the first time I ever had to analyse data for a client, I was lost. I had no idea where the boundaries were. I could produce theory, but I couldn't tell the client what the answer was. And that was a baptism of fire because I didn't do so well, right? And so the goal of this is to get you guys a bit prepared for what the real world will bring you. And the real world brings you this crushing reality that you don't get instructions on exactly what you should and shouldn't do. You just have to work it out. And that's why this course is structured the way that it is, okay? I know it's not easy. I know it's not easy, right? There's good and there's bad in GDA. The good is that it's pretty hard to fail a course, right? So you come and you do the course, you're pretty guaranteed you're going to get through it. But equally, it's pretty hard to feel like you understand everything. And you know, welcome to the world where the sky is high and you don't know where it ends. So you just keep flying, okay? And that's just the reality. Okay, so anyway, in the grand tradition of use the tools that I've taught you, I mean, there's the histogram. You can see it's mildly skewed. It's actually skewed to the left. There's a tail on the left. And most marks ended up sort of in the top bit, right? This actually mirrors the grade distribution we're going to end up with, which is loaded with credits, Ds and HDs and relatively fewer passes. About a third of the class, I think, ends up in the P range. And, well, you can do the math, right? 15% HDs, 20% Ds, 30% credits, you can work out what's left. And they're roughly all the passes, okay? There's the box plot. Look, it's not bad. There are some outliers, but these outliers are people who I think, having got the first assignment back, will go, okay, I need to do better, and we'll think about how to do that in the next assignment. Okay. Now, so questions. Ask me what you want about that. Okay, all good? Yes.
Yeah. And we need to include the graphics in the introduction part and conclusion part.
No. Look, the feedback I got, so these were marked by one of my tutors. I don't know why that's happening. Anyway. Okay. These were marked by one of my tutors. The feedback he gave me was he thought that the introduction and conclusion was actually pretty well done by most people. He thought that, because in previous years that's been a real problem, people not writing an introduction or conclusion, or just, you know, and it's like not starting and not finishing something, just doing the middle. This year that was much better. I'm much happier with that. No, you don't need to do graphics in the intro and conclusion. You can. I mean, there's no rules, right? It just depends on, it depends on what story you're trying to tell and how you want to tell it. Okay, so you have a lot of agency in that question.
Okay. Just show some sample sizes in the drops.
That's cool.
And it doesn't work.
It doesn't, well.
The comments as I used to not include drops.
Okay, well, come and have a talk to me later, and if I think that. Yep. Okay, that's fair. Look, come and have a talk to me later, and I'll have another look. Okay, that's cool. I don't know why this is doing this, but I'm going to turn it off because it's so annoying. I'm just going to put it down here where it won't do it probably. Okay. All right. Any other questions? All right. Okay. Now, so you got your marks on the grade book, and there's some discussion there around, you know, some feedback around what was done well and what maybe could have been done further. Look, I want you to appreciate that it's really hard to write this feedback. The person who marked it had 316 of these, and there's a paragraph to write on each one, so you can do the math. 316, you know, paragraphs. Each one's about, you know, a third of a page. That's 100 pages of typing. Okay, and under the instruction of do this as quickly as you can, right? And he did. So the feedback's not going to be perfect, in other words. It's the best that we can do in the time and given the size of the class and everything. You may not agree with all of it, and that's fine as well. Look, I'm happy to chat through it with you. But again, we're not going to have a... One thing I want to be very clear about is that I'm happy to talk through feedback and all that, but none of this should be entered as a negotiation around how you're going to suddenly get an extra 20 marks or whatever. That's not what it's for. You know, sometimes the feedback might be a bit clipped or whatever, and again, that just reflects the way these things have to be done. In a large class, you know, with time constraints, you just have to do what you can do. So if you have a particular problem with the feedback, or you don't understand some of it, definitely email me and we can chat. But again, don't come with an expectation that you know, I'm going to get 1 mark or 2 marks extra. Look, the truth is, in the context of this assignment, 1 mark or 2 marks is noise. It's noise, basically. And so, you know, we all know not to overinterpret noise. It's the central message of statistics, right? So, okay, now, what did people do and what did I think people could have done a little bit better? So, most people ended up showing me this graphic, okay, which is a pretty good graphic. It's got the 8 groups, and you can see box plots for each of them. There's a bit of a journey that gets you to this one. I mean, you have to kind of convince yourself that each of the distributions are roughly symmetric, because the use of box plots kind of requires symmetry in some degree. And then quite a lot of people look at this and they go, well, that's the whole story, right? But it does tell you clearly there's a relationship here between height, which is that vertical axis, and the 8 groups. Right? You can see as you move across from left to right, group to group to group to group to group, the heights seem to be going up, generally speaking. It's a bit of noise, but generally speaking, the heights seem to be going up. And so quite a lot of people would make the assessment that, yep, it's very clear that height is related to the groups, which are variously pitch and gender groups. But then the drilling down requires you to think more carefully about the groupings in the data. Okay. Now the groupings are relevant because we know characteristics of these 8 groups that bind them in certain ways. And to not make use of that information would be to not seek to understand what the broader effects are that affect height. Okay? And we know there's 2 broad effects in this data. There's pitch, there's gender, and then there's actually a third effect, which is subgroup, right? Because each pitch has 2 subgroups. And you know they're ordered in some way, but that's all you know. Okay? So you're essentially looking for a gender effect, what you might call a pitch effect, and then perhaps a sub-pitch effect. Those are the 3 things you're looking for. Okay. Now this plot here suggests you might have all 3, but it doesn't tell you that for sure, right? And so the drilling down really requires you to try to in a very deliberative way, try and separate out these effects. Now they're not completely separable, which most people discovered, right? Male versus female is exactly the same as low pitch versus high pitch, where low is the 2, the alto and soprano groups, and low is tenor and bass, high is soprano and alto. Okay, so these 2 effects are what in statistical language is called confounded, which is another word for can't separate them, right? If you want to be technical in a model sense, they share the same degree of freedom, okay? And so you can't say unequivocally that those 2 comparisons are different, or that they differ materially, okay? So people who pursued ANOVA models would have found that, yeah, you get somewhere, but because of that confounding, because of that shared degree of freedom, you can't really separate things out the way you wanted to. And remember, the course is called graphical data analysis, right? 1/3 of the name of the course suggests draw me a picture. And the motto of the course is show me, right? Show me a picture. And as I said beforehand, and again, this gets down to what did I expect? I said several times, right? You got to show me in a visualization what's going on. Okay, so just fitting a model isn't the way to go. Okay, now that's not to say fitting a model is wrong. It just doesn't get you all the way that you want to go, right? And so what I thought was a sensible way to go would have been to look at the males and females first, strip out a gender effect first, okay, then see if you can strip out the pitch effect that's residual to the gender effect, noting that you can't separate them out entirely. So in terms of the picture that's in front of you here, what it means is looking at it in 2 halves, right, because at the moment you kind of got this, right, you have to look at my hands now, you kind of got this. So if you remove a gender effect, it's like snapping that picture in half and reshifting. Okay, so fracturing the picture in half and shifting each half down by an amount equal to some measure of that gender's height. Okay, so you can do that. It's pretty easy to do. Again, you can do it through multiple different ways. I've chosen to do it by subtracting off a median. Okay, so we've just created these new things, which are the median corrected groups. And then this is the box plot that results if you fracture that first picture and shift each one down, so that now it's got baseline 0, and you've got 2 groupings, the 4 on the left and the 4 on the right, within each of which I expect there to be structure, right? But now it's centered around 0, and critically, the scale is now your friend instead of your enemy. In the original picture, the scale goes from the smallest height to the largest height, which is a long way, right? By subtracting out those effects, it's like creating, in some sense, a residual plot against a really simple model, and the scale changes so that the effects are magnified visually, right? And that's why you might pursue this kind of strategy. Now, it's now centred around 0. And I think there's still something going on, because now within each group you've kind of got box plots stepping up the page. Not by so much, but you can sort of see they are. This one here is an anomaly, and it's an anomaly because the group's so small. But the rest of them you can see, as you move from left to right, in each half of the picture, it goes low, 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 higher, higher, highest, and so on, right, across both groups. So now what we're going to do is we're going to remove that bigger pitch effect. But you have to be careful about the way you do it. You can't just remove the mean of pitch because you've already removed the grand mean, the mean of gender. So you actually have to look at the means of the corrected values, or the medians, I should say. That's what I'm doing here. Okay, so it's a bit of messing around, and then you get this box plot. So this is now corrected twice, once for gender and once for pitch. And the way to think of this is like taking that plot where original plot, you fracture it down the middle and shift so that you remove the gender effect. Then in each half, you fracture it down the middle and shift. Okay? And now what we should have, if there's nothing left, this should just look flat. And it kind of doesn't. Okay? Apart from the soprano group, where again you've got this anomaly because the group's small, if you look at the altos, it goes low-high. You look at the tenors, it goes low-high. If you look at the basses, it goes low-high. Now, there's tons of noise, so none of this is going to survive a formal test, okay? But this is a visualisation. This is a small effect subject to noise, and it's observable, okay? And that's kind of where the analysis might end, okay? And I think there's possibly even more to say. The people say to me, you know, you mark this out of 50, but no one can get the last 10 points. Why don't you just mark it out of 40? Well, that's kind of what is happening, right? But to get the extra points, you'd have to do something more sophisticated again, which I'm not going to talk about here, right? But it involves hierarchical models because you've actually got nested conditions in here. And that's not something I expected anyone would do. And the marks always top out at you know, mid to high 30s. And again, I don't want anyone to worry about that. No one should go home and cry into their pillow because they didn't get 50, right? That's crying about something that's just silly because 50 wasn't possible. And I'm not saying 50 is a mark anyone should strive for, right? You should just try and strive for the best mark you can get, okay? I've had a long think about whether I should even tell you about 50 being a possible mark because it really isn't. I should just say it's out of 40 and then I don't get all the blowback. But that's not transparent. I mean, so I tell you this. But again, I just want you to be relaxed about the fact that it's not, the raw mark simply doesn't matter. Like I said to you a minute ago, the person who got, 36.5 might as well be sitting on 100%, right? Because in the end, the scaling is a relative scaling. It goes from top mark to bottom mark. It starts at HD, it ends at pass typically. And we work our way down in between. So that's kind of the way it works. Okay. All right, so that's what I wanted to say about the assignment. Again, look, I know that assessment is hard for you guys, and I know how much it means to you, and I know marks are very important. And I don't want you to think at all that I'm blind to that. I mean, I do care a lot about how you guys feel. I do care a lot about, and I don't want to make anybody upset or sad. I mean, it's not me. You know, if I see a kid crying in the shopping mall, I almost cry. I mean, it's just awful, right? I guess I don't know. Maybe I've got high empathy or something. It's obviously a disease I need to work on. So I don't want to make anyone feel upset or sad. And I don't think there's any basis for people to feel upset or sad based on the marks, even though I know when you first get the marks without us having had this discussion, I can understand why people get a bit worried because you see a mark and it looks really low and you think, oh my God, I'm failing. Okay, let's put it on the table. You're not failing, okay, period. There's a separate discussion to be had. I'm not getting the mark I wanted, right? Okay, well, let's drill down on that one a bit. What mark do you want? If the answer is I want a distinction or a high distinction, well, distinction or high distinction means practically getting something like 28 or above, okay? And if you're not quite there at the moment, you can be there after the next assignment in the project. So use this as a jumping point. And the bottom line, and it's really important to say, is that, I mean, I have to produce marks because in the end I have to produce a set of grades. But that ain't the point of us being here. It just isn't, right? The reward comes when you're out in the real world and you get given a set of data and you remember back to lessons that you learned, and it doesn't really matter what the hell mark you got. If you're able to cope in that situation, then we've done what we're supposed to do here at university, okay? And I know marks matter, and I'm not saying they don't. I'm just saying that the bottom line is the learning. So try and use this as an opportunity for learning, okay? Which is the spirit in which I want it to be done, and it's, I hope, the spirit that you're happy to come along with. Okay, so, yes, sir.
So eventually, what factors appear to be important in describing height?
Well, gender's clearly important because it's got a big effect. You can quantify the effect very easily. You just take the median of the males, subtract the median of females, and you can see the difference that gender's likely to make on average, okay?
So this is the fact.
Yes. So the one way I'd answer that question is I'd say, suppose someone is standing in front of you but behind a curtain, okay, and you want to guess their height. What questions would you ask them that would help you have a better guess? And so the first question you'd ask is, are you male or female, right? Because that's going to tell you baseline whether they're going to be likely to be taller or shorter. I mean, that's the first and most important thing you could ask, yeah.
Soprano and soprano 1 and soprano 2,
yes.
Are they two different
Yes,
voices?
yes. Well, they're not two different voices. They're the same voice part, but the data set came with the instruction that they were ordered by pitch. The groups were ordered by pitch. So from that you can infer that soprano 1 was a higher pitch than soprano 2. Okay? And so there does seem to be a subtle, perhaps not significant sub-pitch effect.
So we consider them as a soprano 1 as a entirely different pitch than soprano 2?
Not entirely different, no. You can group them. They share a characteristic. They've both been classified as soprano. Okay? But there is a distinction between them that's subtle. Right? Remember that not every distinction is a sledgehammer distinction, right? So yeah, so if you were to say to me, what do you think is going on in this data? I think there's likely to be a significant gender effect. There's likely to be a less significant pitch effect within gender, but it's nested within gender. And then I think there's a subtle but perhaps not significant sub-pitch effect. That's what I think we end up with, okay?
So how could we get here without comparing other important indices like squeeze and tortoise?
You got the data you got. You have the data you have. That's all you've got. So, I mean, these are human heights. They're likely to be normally distributed. The data broadly supports normality. So, yeah. If you aggregate and you do a density of everybody, you get something that looks pretty bell-shaped. These are small samples, so there's noise. But, and yeah, they're not perfectly symmetric, but I think they're close enough to make some comments, yeah. And again, these are all judgments, you know, and it's perfectly okay to form different judgments about things, but every judgment needs to be supported by evidence, and that needs to be described, right? So that's kind of where we're at. It's hard, is the truth.
Yeah, I just cannot understand why there is a presumption in this.
Presumption of normality.
Yeah.
Well, there's evidence.
Actually, it's not. Yeah.
There's evidence for normality. If you aggregate some of the groups and you look at densities and QQ plots, it's defensibly close to normal. The QQ plots suffer from the little staircase look because there's rounding, and that there's actually a secret in the data that nobody discovered, which is people lie about their heights. You'll notice some excessive if you look at the staircases, you'll notice that the staircases at heights like 65 and 70 at the 5s tend to have longer steps than the others. And that's because people like to round up. So if someone says, how tall are you? You tend to round up to the nearest 5 because it makes you sound taller. And the data shows you that. So my inference based on what I see in the QQ plots is that people lie about their heights. I doubt these are measured. I think they're probably self-reported. So, but again, that's subtle, right? And you know, so, yeah. All right, I want to start talking about the project because let's look forward, not backwards. Eh? Always a good idea. So let's start talking about the project. So let me clear up a couple of things. So first up, remember the project has 2 parts, okay? First part is out of 10, and it says you go and collect graphics from the internet and you give me a critique of the graphics. So dot points is fine. You don't need to write me an essay. Dot points is fine. Look, the more interesting the graphics, the higher your mark will be, basically. So if you hand in 3 boring bar charts, you'll probably get 5 out of 10, okay? If you hand in 3 really amazing looking graphics that you've discovered on the internet and you've got a reasonably sensible critique of them, you can get 10 out of 10, okay? And the idea really, again, is to just say, you know, have you been active looking for these things? Have you tried to find interesting things? And do you have a basic idea of what's good or bad or ugly about them, okay? So it's not, and it's very, look, it's subjective, right? So, you know, but try to look beyond bar charts and pie charts. If you look in the media, 99% of what you find is a bar chart or a pie chart, okay? But there's tons of other really interesting stuff out there, and of course you've seen some of it on sites like Flowing Data and stuff like that, so those are examples. People always ask me, can you use the sites that I've shown you? Yeah, of course you can. I don't know every graphic that's on those sites. I have looked at those sites. It's better if you show me something I haven't seen before, but you don't know what I've seen. So that's not a disqualifier in any sense. But it'd be good if you could search widely for these things. And they're not hard to find. I mean, my hint for people who are struggling, because I always get someone coming up and asking me, how do I find graphics? Well, if you go into Google Images, and you type bad statistical graphic in the search, you'll immediately have about 1 billion examples. So it ain't hard to do. It ain't hard to do, okay? And I know I'm not revealing any secrets there. I mean, if you don't know how to use Google, how did you get to where you are now, right? So I've even got the hat, so it's all good. So part A is not meant to stress you. It's just meant to be fun, really. And look, the one effect I think this course does have is over time, people email me. I've had emails from people I taught this course to 20 years ago, and they email me a graphic they just found at work. They said, you won't, you know, and the subject of the email is, you won't believe this, Michael, right? And it's always some awful graphic that is going to, you know, dictate a big decision at a major company. It's like, oh boy, here we go. Right? I'll be reading about the collapse of this company later. It's kind of like a visual form of insider trading. You know this company's going to fail because they suck so much at producing a picture. So, okay, let's talk about the 2 data sets. So there are 2 data sets that you can choose between. So the first one's called Otter. So I'm going to talk about that one first. Okay, so there's the data, a lot of data. Okay. So I'm just going to scroll back a bit, see if I can get to the top. There it is. Okay, so here's the story. Otters, well, Google image otter, river otter, and you'll see pictures of them. They're very cute. They're covered in fur. They live in the water, and it's cold in the water because they live in cold places, and so their fur is protective. Okay, so it's really important that their fur is functional, and so they groom each other. So they try to get each other with nice fur, not so they look good, but so they survive the cold. Okay, and so there was a study done of the grooming habits of these otters. Okay, and in this study, you had otters within different enclosures. Okay, and then people sat and watched them, and they counted the number of times in each group one otter groomed another otter. And they also took note of whether it was the breeding season or the non-breeding season and that kind of stuff. Okay? So, I'm just going to focus on the first element of each subpart here. So otter dollars group is the group they're in. So the first observation was in Group A in the non-breeding season. So I'm just looking at the first element of each vector here in the non-breeding season. They were watched for 127 minutes, so a little over 2 hours. And during that time, F1 was the groomer of M2, who was the groomee, and F1 groomed M2 exactly 6 times. Okay? So that's the first observation. Let's look at the second observation. Same story. We're still in Group A, still the non-breeding season, still 127 minutes. So this is the same viewing session. And you can see that 127 is repeated. So within each viewing session, you're looking at different pairs of otters, right? And F1 groomed M3 once, okay? And so you start to build this picture. For the first session, which was 127 minutes long, F1 groomed M2 6 times, F1 groomed M3 once, and you can see the third one, F1 groomed M4 twice, okay? And then you cycle through the other pairs, okay? You can see, you look at the fourth one, you're on to M2, grooming, F1, and so on, okay? So, 0 times meant didn't happen.
Why do we have like grooming and
Oh, because every pair has a possibility of grooming. So that 0 means that that pairing did not groom during that observation period, but during another observation period they might, because the otters are watched for different periods. Okay. So let's sort of get you started. The first thing you're going to want to do is break. You're going to go something like group equals otter dollars group, because you don't want to be typing that all the time. T equals otter dollars time. Groomer equals otter dollars groom groomee equals otter dollars groomee, and so on. Season equals otter dollars season. All right? Now, let's suppose you wanted to know the number of times in total that F1 groomed M2 through this entire data set. Okay? You'd go, what's the sum of when groomer is F1 and groomee is M2. So in the total data set, F1 groomed M2 15 times. So you can use sums to aggregate number of grooms. Now the secret to getting started on this particular project is you're going to be using a lot of statements that look a bit like this, right? A lot of statements that look a bit like this, combining different conditions to reflect a certain grooming pair or to reflect what happens in a certain season. So for instance, if you wanted to know the number of times that F1 groomed M2 during the breeding season, you'd do that. And during the non-breeding season, you'd do that. Okay? So you'll be using these conditionals a lot, and this is to create aggregates. Okay? Now remember, you've got time in there as well. So obviously if you watched for longer, you might groom more. So you might want to consider, how do I take those frequencies and use time to produce a meaningful quantity that I can compare? Okay? So for example, if one pairing groomed 6 times in 100 minutes and the other pairing groomed 6 times in 200 minutes, you can make a comparison, and it's pretty easy to work out what you'd do. Okay? And so this is how you'll build a set of data around how many times certain things happened, at what rate they happened, comparisons when there's breeding versus non-breeding and that kind of thing. Now, the kind of tools that you'll use graphically will be things like we did early on in the course. Things like bar charts, things like box plots, things like maybe densities. Okay, you've got to think about how you might bring these into play. But what I would suggest is you start by trying to break down the different combinations using these kinds of ands. So the two operators you'll use most often are and, ampersand, and or is the vertical line. So ands and ors will let you create conditions that you want to compare. Now, the data set has 4 questions it wants you to answer, right? Do otters exhibit preferences? I forget the others, but is grooming more prevalent in breeding season versus non-breeding season, those sorts of things. So you don't have to make up your own question for this data set, just answer the 4 questions that are there. Once you answer one of them, it'll be pretty clear how to proceed with the others, right? But today is all about just saying, this is how to get you started. Just try and break down the data using these ands and ors, using sums and rates and different things like that to try to get a handle on what's going on in this data set. In its raw form, it looks pretty forbidding. Once you make a start at combining and aggregating and that kind of thing, you'll very quickly get a sense of where to go, okay? Structurally, I don't think it's a hard assignment, a hard project in the sense of the things you have to do to aggregate the data and everything, but most people find working with lists a little bit difficult, so I just wanted to get you started with that. Okay? So that's the otters. So I'll leave that with you for the moment. I know you'll have questions, and that's cool. We'll proceed with questions via email as normal, right? But for the moment, that's to get you started.
If we show the data on the graph, as to which you need to write down in the task.
Do you need to do any tests? If you want to, but you should proceed as visually as possible.
Yeah.
So,
I mean, do I need to duplicate things?
No.
Yeah.
No. One of the big issues people have when they do a course like this is you get taught all these different techniques and people feel like they have to use every technique for every problem. But that isn't how life works. The way life works is you use different tools for different problems. It's just important you have a big toolbox with lots of tools in it, right? So the judgment, and the reason there's a page limit on these things is you have to make judgments around what tools are better and what tools are not as good. So for example, in the assignment, a lot of people showed me QQ plots and they were more or less useless because of the step function part, right? They didn't really show me anything. Much better off sticking with densities, right? So there was elements of choice that I thought people overchose, right? They're like, well, since you taught us QQ plots, you must want us to show you QQ plots. Well, no. The direction was, show me the most effective story, right? And so sometimes that means not doing certain things. Sometimes it means doing other things. Okay? All right, let me talk quickly about the insurance data. Okay. So this is about what's called redlining, which is an illegal practice in insurance underwriting. So the story is this. This is in Chicago. Chicago is a city that's got a very high crime rate, very high poverty rate, but it's also a city that's broken down very much by race. You've got large ghettos of largely black people and run-down neighbourhoods and that kind of thing. So you've got zip codes here. So there's a map which you can download from the Wattle site. And so the zip codes tell you where on the map everything is. And then for each neighbourhood, you've got the percent racial composition. So you can see, you know, there's I think one of them here is over 90%. Yeah, 95%. That'd be a neighbourhood that's almost all black. Then there's some neighbourhoods that are almost all white, right? The 1%ers, right? Those kinds of things. So you've got racial composition. You've got a fire index, so that's amount of fire activity, theft index, age of housing, and then you've got average income, okay, for those neighbourhoods. And we're looking at housing insurance. Now what happens is people come to the insurance company, they say, I want to buy insurance. The insurance company determines on the basis of risk elements whether they'll insure them or not. So some people get declined insurance, okay? They're just told, we're not going to sell it to you, you're too big a risk. Now you're allowed to decline insurance on certain bases, right? If there's a high theft rate or a high fire rate, They can decline you, they don't have to insure you. What they can't do is look at you and go, oh, you're black, we're not insuring you. That's illegal. That's discrimination. Okay? So what we're looking for in this data set is evidence that race matters in decisions around insurability, but then there's these other variables in there that are interacting with race that are valid underwriters. So again, it's one of these problems of separating out effects.